trying to get this to work. Okay, so yeah, so no fines concrete versus permeable concrete. And you can see there the cars in the background. A little while ago, a couple of years ago, we actually did some work on the block. So you can see there in the background the block cars. So we did a permeable concrete driveway at the back of that. It was really exciting to be involved with such a good TV show, and it was very stressful, but geez, we had fun doing it. It was really good. So the function of no fines concrete and permeable concrete is to construct a bonded concrete material designed to absorb rainwater and stormwater runoff to reduce the effects of flooding and return the water back to the water table via natural passing flow. So that's really what no fines concrete or permeable concrete does. That's the purpose of it. And the most common name that you'll find in the industry are, I suppose no fines is the one that everybody really relates, permeable concrete to. And then the sort of the lesser names are permeable concrete. Pervious concrete is used a lot in the States and in Europe, and then you've got porous concrete. They all mean the same, they all do the same, just a slightly, depending on where you live, it has a different name. Here in Australia, no fines has been probably the most commonly used. And there you go, just sort of talking about that now. So, no fines concrete is a lightweight concrete made up of only coarse aggregates, cement and water. And by omitting the fines out of like a normal ready-mix concrete, you then produce a no fines permeable concrete. That's pretty basic. There's only 3 elements to no fines concrete, and there's only 3 elements to permeable concrete: cement, aggregate, and water. No fines concrete looks like that. It's quite dry and pretty gnarly, and is made up of usually made up of 20 to 14 mil blended aggregate. Has a cement to aggregate ratio of 8:1 and a water cement ratio of 0.4. Now, a mix of this kind here is probably gets a typical NPA strength of around about 7.5. The reason for that is that it does have a lot of aggregate and not a lot of cement. So it's really just a consolidated loose stone. And that's pretty much what no fines concrete is. And hence there are quite a few issues with that if it's ordered and used in the incorrect environments. So if no fines concrete is used in the wrong environment, it can go pretty pear-shaped pretty quickly. So you'll see that as I move through the slides a little quicker. Down the track further, you'll see that. Having trouble here moving the slides for some reason. So yeah, no fines concrete applications. No fines concrete is best suited for non-trafficable applications due to its low cement water ratio design. Applications mainly used for retaining walls, a little bit behind retaining walls, to allow the water to egress down the side of the retaining wall or the back of the retaining wall rather than pushing hard up against it with sort of hydraulic pressure. It's used as a sub-base for brick paving. So you put that down first and put some brick paving over the top of it. And you keep the gaps a little bit wider and the water can pass through that with a nice hard surface, a nice hard wearing surface. A sub-base drainage layer, and whatever drainage is required and they can afford to have a protective top layer over the top of it. Because if we don't have a top layer over the top of permeable concrete, no fines, it can break down pretty quickly. So no fines concrete shouldn't really be used as a finished product and have traffic going over. When I say traffic, it's more vehicles, car loads and so forth. This is a perfect application for no fines concrete. As you can see there, that the guys are loading up the no fines concrete in the back of the retaining wall. That's exactly what sort of permeable that no fines concrete was designed for, is to backfill behind retaining walls, and it's the best way to remove hydraulic water pushing against the retaining walls. You can see there that that's exactly what it's used for, backfilling behind the retaining walls and core filling the block walls. So that's what no fines is good for. It's not to be used, as I said, for trafficable applications. No fines concrete has been used in the building industry for many years, usually for the purpose of backfilling retaining walls and trenches in non-trafficable areas. Usually it's open structure and large aggregate no fines concrete has a very low breaking strength and is susceptible to crumbling and rattling. Now, rattling is where the top surface sort of, you scuff your foot across the top surface, it becomes almost like a gravel, like a stone. So that's quite inherent with no fines concrete. As I said, no fines concrete is not recommended for vehicle load applications. It can be used for vehicle load applications when you have a wearing course on the top of it, whether it be a brick layer or a concrete paver of some sort. So when you have the vehicles sort of travelling over the top of it, you've sort of got the consolidated strength of the no fines concrete underneath, but you haven't got direct contact with vehicle wheels and tyres to crumble it down. To enable most effective infiltration, no fines concrete typically uses aggregate size of 14 to 20 mil and upwards. Using a 14 to 20 mil doesn't really lend itself to be looking very nice from a visual point of view. So that's another reason why contractors, or it's designed for a top surface to go over to make it look appealing. That's a close-up of a non-trafficable no fines concrete, so you can see that it's quite gnarly and doesn't really look the part when you're using that as a finished product. So you want to be able to cover it over with some bricks or a lot of people nowadays use a resin bonded aggregate over the top, which is again porous or permeable to allow the water to go through, and they put that in at a almost like a 10 or 15 mil layer over the top of the no fines concrete to make it look pretty. Now this is a no fines concrete driveway that we replaced a couple of years ago because it was again used probably wrong product used in a driveway, and this is what happens pretty quickly to a no fines mix on a driveway when traffic is driving on it. It really loose. So it's yeah, I'll just play that again so you can have a look at it. And dig it all out, and repair it with without permeable concrete. And that's what it looked like. It was in what they call a tree protection zone. That's really quite typical in a lot of the environments that we do a lot of work in. It's on the left-hand side there. You can't really see it in the photo, but on the left-hand side there's a nice big gum tree there, and the council wouldn't allow concrete in those areas, and that's a policy through most of the councils throughout Australia. Mainly this one's in Melbourne, Victoria. That area there couldn't be concreted. It had to have a medium or a product there that allowed the water to go through back into the ground again to feed the roots of the tree. So obviously people didn't realise that no fines concrete wasn't the right product to put in. So we went ahead and installed our dry con system, just a permeable concrete. And that's it there. Like you can see the gum tree in that. That's after, of course. So that's our permeable concrete system in place. Now that edge border there was put in there to hold the no fines together. We left it in there just as we didn't really want to take it out. It looked okay. It was in good condition, so we left it in there. It actually framed the our permeable concrete nicely. So our product doesn't need any concrete edging to hold it together, but we just left it there because it looked quite nice. This here is our, I think this is actually the photo or video of the water going through that driveway. So that there is the flow rates that you can expect from a trafficable permeable concrete with the correct mix design. That's at full speed, so that's real time. So you can see we have a nice solid structure of permeable concrete with the correct mix design. The water flow rates are quite amazing. So now we get to permeable concrete. And permeable concrete, as you can see by that photo there, you can see that the paste content is covering the whole rock, and you're getting some nice bridging there of the paste. So that's what really gives the strength to permeable concrete. So permeable concrete is a durable concrete pavement with a large volume of inconnected voids, approximately 20% void ratio. We try to hit anywhere between 15 and 20% with our mixed designs, and most of the time we're up around about 20%. The like conventional concrete is made up from a mixture of cement, fine aggregates and water with the addition of sand. This results in a porous open cell structure that allows water to pass through it readily. Typically a small aggregate is used, and you can see there we use like a 5 to 7 mil, with an aggregate to cement ratio of 6:2 and a water cement ratio of 0.4 to 0.5. So that's quite different to no fines concrete, and that's why we get the strength in the permeable concrete. It is a completely different mix design to no fines concrete. A lot of people don't realise that, but it is a completely different mix design, and that's where it all starts from. Mix design for permeable concrete that is used for trafficable installations is vastly different to no fines concrete. Permeable concrete has been especially engineered to withstand vehicle loads, has a high cement aggregate ratio to form a strong matrix. It contains additional admixtures to enhance the strength and workability. It can be made from smaller aggregates which have more visual pleasing surface finish. So we can actually get down to a 1 mil to sort of a 3 mil blend of aggregate as well and it still is very permeable. It just lacks a little bit of strength. So we find that the 5 to 7 mil is the best aggregate to use. There again, a close-up of a trafficable permeable concrete, dry-con product. Now you can see that it's quite moist and it's a high content of cement in it. And you can see that the cement is actually bridging across the aggregate to hold it all together. And that's what you're trying to achieve when you're producing a permeable concrete. These are just a few tests that we do for our permeable concrete. And this is sort of quite outstanding performance when you can have a truck driving over a suspended permeable concrete slab with no reinforcement in it. That's something else I forgot to mention. Permeable concrete shouldn't have any reinforcement in it, like mesh or steel. If you put mesh in permeable concrete, you can actually, because it's reasonably dry, you can actually start to hit voids underneath the mesh. So the permeable concrete doesn't really consolidate around the bars of the Rio. If you really wanted to do it, you'd have to sort of hand compact around each and every bar to make sure that you've got the permeable concrete underneath it. A lot of the time you can't do that. It's just cost prohibitive and too labour intensive. So it's best to not have mesh in there at all. A good mix design will support permeable concrete if you've got the right mix design. So I'll just play this video here. That's that minimum driveway thickness that we would put in a residential driveway of 125 mil, and that's got a 6.5 ton truck backing up on it and suspended. So you can see by the mix design and what we've achieved there is quite amazing for a permeable concrete. You just couldn't do that with a no fines mix. It just doesn't have the strength in the mix design to hold it together. So what I'll do is I'll just quickly play that again, just so you get a chance to look at it again. This is our permeable concrete in action here. Just another photo video of how the water penetrates through permeable concrete. Another car park. So, I can't stress that enough. A mixed design that has the right amount of aggregate and cement in it that can withstand traffic going over it. You get a really high infiltration rate. It's another, just a small video here of the ability for the water to absorb. That was the colour was a red oxide actually in the cement. So in order that way, and if you use permeable concrete, you can actually have an oxide colour put in the mix prior to it coming to site, and it doesn't really matter what colour you put in it, you just treat it like normal concrete. Again, the mix design is imperative that has to be correct. Now, to test our permeable concrete and the infiltration rates, this video that we're doing here demonstrates the water infiltration rate of our dry permeable concrete carried out to the ASTM standard 1701. This results in a water flow rate of greater than 500 millimetres of water, or 500 mil of water per minute, which is more than 30,000 milliliters or millimetres per hour. So this is, I'll show you the video here. This goes for just on 25 seconds or so, so bear with me with this.